Welcome to my talk. So I'm up against machine learning and things, so that's a big crowd draw, obviously. I've not got everyone in here, but I'm here to speak about something I'm really passionate about. Or is it 2 things or 3 things? So I've got 3 things that I'm really passionate about, and I've hopefully got 3 demos that might work as well. So we're going to try with at least one of them working. So I'm talking about the cloud-native release engineer. So does anyone know what a release engineer is before we start? Well, I've got a little bit to fill you in, but yeah. So I'm actually talking about building my hobby projects on Civo. And you can find me on Twitter at Martyn Codes, or you can find me on my rather boring website, which is hosted on Civo and has been there for quite a while. Occasionally falls over, but it's quite reliable. So I'm here to talk about being a release engineer. I also am a real train engineer as well, if anyone's interested. But also I'm a campanologist, and I'll come to that in a second. But most importantly, my career is a Python developer and cloud lover. So I really love working in the cloud. I really love writing Python, maybe too much, and that gets me into a lot of problems at home. My boyfriend is not too happy that I write code, except when I write his code. So it's fine when you're writing someone else's code, but when you're obviously writing your own, it's not good. But yeah, so what is campanology? So I've been doing this for 25 years, which might show my age, but also I started really young. So this is somewhere I ring. So I ring effectively what are church bells. We have one round the corner at St Paul's Cathedral. But this is Liverpool Cathedral where I was ringing in February when I was talking to you about doing this project. So they are the heaviest ring of bells in the world. There are 12 there. So you might think that this is something really British and change ringing is a British thing, but actually we have bell ringing spans as far as the US. So if anyone's from Washington, we have bells out in Washington. We have all the way through the parts of Eastern America that may have been at once settled in by people from this country. But we also have people who ring all around the world. Also people from the UK also may have made it to New Zealand and Australia, so we have church bells there. And there is the heaviest ring of 16 is actually down in Australia. So why is this important? Well, you're probably thinking, what am I on about here, right? You've come to a tech talk, and yet I'm talking about change bell ringing. Well, the 2 things can come together, and this is where you bring your passions together. That's what I kind of talk about. So I'm talking about demonstrating your skills as a cloud-native developer, and really practicing skills I've picked up. So the other side of this talk is about being a release engineer. So this is where you will get really bored, and if anyone knows the lingo, they will start to fall asleep, and probably I'm going to see people walk out, right? So I'm a release engineer. That is a safe terminology. So if you don't like safe, you should leave now. Or maybe you want to know why you like safe. So I take a really different approach to being a release engineer. Most people think of it as a project manager. I do not. I hate people who do that. I am someone who will get in there and write code with the developers, and I will teach them what to do, because that is how I interpret that statement from the Safe website, which I extracted the other day. So that is what Safe says, and that's my interpretation, is to coach, support, value, and drive improvement. And I take that literally, and I do the work. And I'm going to talk about how I do that. So here's the other problem. Is change ringing in decline? How do we support its future? How can we measure the health of the hobby? So this is what I want to solve from a personal perspective. But in my work, I want to solve a different problem. I want to talk about how do you show off technology that you've learned. So Kubernetes, performance testing, Flux. These are kind of key things that we all need to know to do our jobs as cloud developers. And I'll explain why they're really important in a minute. And this is all keeping up with new tooling. So back to the bell ringing side. This is something called Bellboard. If anyone is a bell ringer, they would know this. It's a pretty ancient piece of kit. If you look in deep in there, you've got XML, horrible stuff. It's written in PHP. But it's been going for like 20, 30 years. So what is this? It's a legacy application. It's got poor insights, and we can't use it for data science, which is kind of where I'm going with this talk. But I should have hidden the bottom bit if I forgot to do that. But does that problem sound familiar, right? Legacy data, poor insights and querying, you can't use it for data science. I certainly find this familiar because in my 10 years, 12 years as a software developer, 10 of those have been doing exactly this problem. Taking legacy applications and making them not modern, but making them work. Getting insights from legacy applications and doing data science on legacy data. It's a big market and a big thing to do. And my current project, Thermo Fisher, we are doing this. We are taking data from legacy instruments, bringing them to the cloud. So, oops. We're going to load this data and we'll load it elsewhere. Also sounds really familiar. And so, basically, the problem I'm saying here about bell ringing and the data from bell ringing is the same problem I faced the last 10 years in workplaces, right? And it's a simple ETL problem. Extract data, transform data, load data. And you can boil it down. And what that means is I can relate my working skills and the working skills that my teams around me need to know and do into something that I'm doing at home. And you can learn new skills that way. So the project, basically, that I've started setting up, we were talking about it the other weekend at our annual bell ringing conference. We want to build a cloud-native ETL pipeline, and I want to do it on Civo because I've been working with Civo for a long time. It's really cool, but it's also cheap, right? Bell ringing is not a rich hobby, although they have a lot of money, but no one wants to part with it. So we want something that's cheap. We've got all the tools available, and we can do it in an open way. And all the things are reusable, and the Civo sort of mindset around kind of doing things that are really flexible is really valuable. And I can take these back to teams and show them how to do things. So I'm going to be building a ETL pipeline, or a job that basically takes data from A and writes it to B. It's going to do that with the Civo Cloud database, and it's going to do the deployment of the application with Flux, if it worked. And I'm going to put observability with Prometheus. I'm going to do performance testing with K6. So hopefully some of those tools sound familiar. If those tools don't sound familiar, then you're in the right place because you're learning around tools there. And so what I do is I work virtually with loads of people now after COVID, but I do lunch and learns with my team. So I go, this is how we use this tool. Here's a practical application of using, for example, Flux. Here's a practical application of using K6. So why is it relevant that I talk about using Flux, for example? Well, in Thermo Fisher, we have a tool called PX Install. It isn't brilliant. It deploys our applications. But it requires a lot of management, a lot of overhead. And it's basically just doing Flux. It's a very complicated way of writing code that we maintain internally, and we could have just used Flux. So what I've built is I've built a tool that I can take to my developers and say, actually, why don't we use this open source tool that's available freely, that works nicely. This is how it works. This is how you use it. Oops. I talk about Prometheus and monitoring. Now, when I looked at the projects that I was supporting, I looked at them and go, hang on, it fell over. No one noticed. Why did no one notice the thing fell over? And they were like, oh, yeah, well, we just wait and we took Datadog down because it was too expensive. And I go, well, Prometheus can tell you when your nodes are down. They can tell you when your jobs are down. And so, again, there's an opportunity here to use Prometheus and Node Exporter and any other custom metrics you build in. So I've built, again, a tool which shows you how to build custom metrics, scrape them with Prometheus, and ingest them into a thing and show them on a chart. I've not got a demo of that today, but I do have a demo of how to do performance testing with K6. So K6 is a cloud-native performance testing tool. It's probably worth a talk in its own right, giving all the sort of bells and whistles a show. But I'm going to go a brief overview. Now, we use at Thermo Fisher, we use Load Runner because somebody paid a license for it 20 years ago, and they love it. But I'm like, let's use something more modern. So let's use something cloud-native. Let's use something that runs in Kubernetes in the same way that we run our jobs. So I'll show you that in a second. Right, so here's where we go with the live demo bit and see if this works okay. Right. Right, so last night I was hastily getting my demo ready. And here's some data that I scraped down. So this is the latest data from Bellboard. It spans everything back as far as May, basically, or at least it did last night. We've downloaded it. And so what I've done is I've basically copied the data into a database using a little sync tool. But let's see if we can make it work and do some tests on it. So what I've got, if I blow this up, so I've got here a very minimal thing. I'll make that a bit bigger. So it's not, there you go. It's not particularly exciting, but what it does is it tells you that we're going to run K6. It's going to run the InfluxDB version of K6, which is something you can look up on the web. And it's going to basically post it to my Influx, which is running on the same host. Not doing a particularly brilliant performance test because I'm performance testing the machine and running it on from the same machine, but you get the point. So if I execute this script now, it will kick off and it will go and run some data. It's applying some load. It's got like a random ramp up, and then it's going to pull some stuff down there. So it's currently ramping up to a lot of users. There you go. It's not happy because it's put some data through. But it's basically pushing data through the system there. So it's generating some artificial users, which is looking at that page which I showed you before. What's interesting about this page while that's running is if we scroll down this page, see how slow that cursor bar is moving. This is pulling data from a database, so it's kind of a bit representative of there. If I'd had more time, I'd make it more interesting, but I didn't want to build a page-generated API. I really didn't have time last night. But it does prove a point that I can now, hopefully, show you the numbers of stuff in here. So let's see. Influx is probably not happy because it's ingesting the data and indexing at the same time, so let's wait for it to finish. But yeah, so what I'm doing is I'm posting the data from the performance test into Influx. And it's currently looking for its things. There we go. Let's kill it. It should have enough data in there now. There you go, live demo. It doesn't always work as you want it to, so it doesn't want to stop either. There you go. Should we stop it now? Oh yeah, right. Let's hope this has got some data and we can go and look at them, right? So, HTTP requests. Right, let's try that again. Right, I'll try again on a lower load and see if it wants to behave itself now. So it's going to put some load through. Hopefully it can... Right, OK. And refresh it. There you go. It's actually got some data now. So if you see here, there is a tiny amount of data going into the system. It's showing it's being used. It's basically got one iteration running at a time. If I was actually able to tune the system correctly, then we would see other things. But you can see that it's receiving data, it's sending data. We can look at the number of HTTP requests that fail, which is not selected. Which is not got any HTTP requests failing, so that's also good. We can see that it's sending in data. So it's currently sending in one request a second, basically, or one request every time. So it's not particularly stressing the system because it's basically running off the same machine. There you go. There's the number of the time it's taking to do the request. So it's as it's requesting more and more data, it's getting more and more things out. So the point of this here is I'm basically going on and learning how to run tutorials and following instructions along, and I can then go and take this to teams and say, how about we use K6 to do some performance testing rather than load runner? It's an easy thing to write. It's written in JavaScript, although it doesn't run in JavaScript. So you could see there that the actual server's starting to time out now, which is what we were seeing in the graph, basically. So yeah, the request times have peaked because the database isn't happy. And yeah, you can see some summary stats in there that it's getting, starting to get timeouts now. And that's all the test takes to write, so it's basically just getting some data. You can configure it in what other way you want. So back to my slides, which is on. Okay. So I talked there a little bit about some of the performance testing aspects. The other bit I wanted to talk about was doing some more interesting stuff now. I came from background before I went into doing software. I used to work in data science and astronomy and things, and I used to use Jupyter notebooks a lot, and this is a kind of a cool way of doing it, but we want to look at the data in a different way. So if this works correctly and doesn't die, we'll see if it wants to work. But we want to look at the data and do things. So this sort of goes back to the bell ringing problem again. We want to look at the history of it. So what I did last night, because I prepared my demo in advance, and Jupyter captures screen logs, screen captures in things. So I've taken the data and I've basically binned it according to month for what's happened. Now, I only was able to sync before I went to bed last night 4 months of data from the database because I wasn't tidying my code up at that time. So we can look at the number of performances, which is I've just taken a very simple capture of the number of things that went on that were logged in the system. And it seems that a lot of things happened in May. I can't think what happened in May. Does anyone know what happened in May? I've completely forgotten. Exactly. And this is why it's really useful. And this is why it's actually kind of really relevant. So we had, unfortunately, just over 12 months ago, the Queen passed away. There was a lot of activity on Belbord on that day. There was also a lot of activity a month or so later when the funeral happened. And then when the coronation happened, there was a lot of activity. And this kind of is a really good way of showing there. Bell ring actually did a big thing about ring for the king, and we had loads of people recruited to come and ring for the coronation. And so some of those will be in this data here where they've logged in to show there. And we can start using this data. And the idea here is, although the project's only just starting and these are the initial insights, we want to start using platforms like Civo to try and say, can we do something in a really affordable way that's not on AWS, that is a lot cheaper, doing some kind of valuable insight. So we can see there was a massive peak here in May. There was a little bit in some of the months. It started to gradually climb up, and then obviously we've not finished in September yet. I've not weighted it. But August was quite busy as well. I don't know, maybe everyone's on holiday. If this works, it might give me a new graph. I think it's still calculating. Right, let's add in, I think I put some more data in, so I can put in a extra one. So if we add in April, we'll see what happened in April. Where we test my live typing. Hey, there you go. So we've added in April's data. Again, Jupyter Notebook really efficiently. So we've added April. We can see that it didn't really climb much, and there's a kind of continuous thing. So you can see the national events in the data. Thank you. Coming on, there's more aspects of that data. So if I go back to that data that I showed you before that I kind of pulled off, this one here. So this is basically just a nice, pretty view of the data in the database. I've removed some of the other stuff that we're interested in. But you can see here we've got the date, which is what I've just been doing some stats on. I'd rather do some more interesting stuff, but for the purpose of this talk, let's keep it simple. This is the number of changes. This is really a measure of time. So to give you a measure, 120, that's about 20 minutes, maybe 15 minutes. 1260, that's 45 minutes, give or take, depending on which bells you bring it on. And 5152, which if anyone's interested, it's roughly 4 times 1260, roughly, works out about 3 hours. This is where we get into the details of how bell ringing works and the methods. But basically, anything that's got like a 5 and then 3 zeros, that's roughly 3 hours. And that's called a peal. And then we've got quarter peals, which are the shorter, about 12s, but they can be different ones, depending on the number of bells you ring it on, number of permutations. But anyway, we can do some stats on here. Looking at the lengths, you can look at the lengths. And you've got the names, and these are what we call the method names. And one of the things that's really interesting is what's popular as a method. So we can pull this, but what do you notice from the data on the right-hand column? It's similar, but it's not all the same. So there's general ringing, plain bob doubles, there's granted triples, Cambridge surprise minor, and then someone's got spliced surprise major, which if anyone knows about bell ringing, they're similar. What basically people can just free text enter into this last column, so you get data corruption. And so one of the things I want to try and do is use machine learning to try and pull this data in and look for better insights in it. So that's kind of where this project is looking to go with and what we're looking to use Civo for. That is not my slides. But yeah, so I'm kind of trying to build a hobby project, learn a load of new things, and help to develop myself. Now, please don't judge me on my code because I didn't get time to finish it because I've actually had my real job to do. So I had to hastily scratch together bits and pieces. But I have sort of been able to bring some stuff together. So what I'm really trying to get across to you here, and the whole purpose of this 25 minutes, was go explore and learn. Go and get something you're passionate about and take it and learn something new. Build your own things on Civo. I'm not being paid to make this talk, but they did let me stand here, so I have to give them something back, right? And I've used Civo for many years. They're a brilliant provider, and they've got some brilliant things coming up with that we heard yesterday. So sustainability, they're things I want to bring into this project. And the kind of machine learning, I really want to use those tools when that comes online. And they've got all these things there, so go and use them and go and learn them. But as a necessary caveat, other cloud providers are available and they may be more expensive. So all I want to say is basically go and learn something new and take it back and teach other people. Like, I'm going to take this when I've had time to write it and get it right and teach people how to use K6 and do performance testing properly on our new cloud provider and teach people how to work with Flux. And if you don't want to pay Civo money, you can just buy Raspberry Pi. And I'm not paid by the Raspberry Pi Foundation, but I do own too many. That is another of my many addictions. So I think we have a couple of minutes for some questions. If you want to leave me some feedback on the right-hand side, it'd be great to know more. And then you can catch my details on there. So.